Unlike all other creatures on this planet, we are the only ones who know that our time is limited. The nature of life, death, and consciousness has fascinated humanity since the dawn of time. For millennia, people have wondered what happens in the final moments before death. Is there a light at the end of the tunnel, a grand reunion with loved ones, or simply the cessation of all existence? In a groundbreaking turn of events, modern science is finally providing answers that delve into the very nature of consciousness, and the discoveries being unveiled are as fascinating as they are horrifying. Scientists, armed with cutting-edge technology and breakthroughs in quantum mechanics, neuroscience, and biology, have turned their focus to understanding what happens in the brain in those final seconds before life slips away. One of the leading voices in this field, Michio Kaku, has described recent revelations as nothing short of revolutionary and terrifying. Before diving into the details of these discoveries, let's explore how this question has captivated humanity and science for generations. Ancient texts, spiritual leaders, and even modern philosophers have posited theories about the moments before death. Many near-death experiences, or NDEs, involve stories of lights, tunnels, and even out-of-body experiences. But scientists now believe that these phenomena may not be spiritual at all. Instead, they could be the result of a terrifying cascade of events in the brain. In 2023, a group of neuroscientists conducted an unprecedented study on patients who were on the brink of death. By monitoring brain activity in real time as individuals transitioned from life to death, researchers were able to capture what can only be described as the brain's final symphony. To their surprise, they discovered a sudden and intense surge of neural activity just seconds before the heart stopped beating. This surge, which researchers have nicknamed the death spike, is unlike anything observed during normal brain function. It's as if the brain suddenly goes into overdrive, processing information at a rate far beyond what's experienced during regular consciousness. But here's where it gets even more unsettling. The patterns of neural activity during the death spike closely resemble those associated with vivid dreams, intense fear, and even psychedelic hallucinations. For years, people who've had near-death experiences have described entering a realm that feels more real than reality itself. They talk about seeing long-departed relatives, feeling an overwhelming sense of peace, or witnessing their life flash before their eyes. Scientists now believe that these experiences may be rooted in the brain's desperate attempt to make sense of its impending shutdown. One of the most common phenomena reported by individuals who've experienced near-death episodes is the infamous tunnel of light. For decades, this has been interpreted as evidence of the soul leaving the body or a transition to the afterlife. But neuroscience offers a far more chilling explanation. When the brain begins to lose oxygen, one of the first systems to be affected is the visual cortex. As oxygen deprivation sets in, the neurons responsible for processing visual information begin to misfire, creating the sensation of a bright central light surrounded by darkness. This, scientists believe, is the origin of the tunnel of light. But it doesn't stop there. The brain, in its oxygen-deprived state, floods itself with a cocktail of chemicals, including dopamine and endorphins. These neurotransmitters are designed to dull pain and induce a sense of euphoria, perhaps as a way to ease the transition to death. However, the combination of these chemicals and the brain's chaotic electrical activity can also induce vivid and terrifying hallucinations. Michio Kaku has long been a proponent of exploring the quantum nature of consciousness. In recent interviews, he has discussed the possibility that the human brain may act as a quantum computer, processing information at a subatomic level. If this is true, it raises profound questions about what happens to consciousness when the brain shuts down. Recent experiments in quantum mechanics suggest that particles can exist in multiple states simultaneously, a phenomenon known as superposition. Some scientists have speculated that consciousness itself might be a quantum phenomenon, existing both within and outside the physical brain. If this is the case, then the final moments of life could involve a breakdown of the boundaries between our physical and quantum selves. This theory has led some researchers to propose a chilling idea, that the moments before death could feel like an eternity. If consciousness operates on a quantum level, time as we understand it may lose all meaning in those final seconds. For the dying individual, this could mean experiencing a seemingly infinite loop of memories, sensations, or even fears, all compressed into the final moments of life. While many people associate near-death experiences with feelings of peace and tranquility, not all reports are so comforting. In fact, a significant percentage of individuals who've had NDEs describe them as deeply unsettling or even horrifying. Some report being trapped in a void, unable to move or escape. Others describe reliving their worst memories in vivid detail, as if their brain is forcing them to confront their greatest fears. There are even accounts of people experiencing what can only be described as hellish visions: fire, torment, and a sense of overwhelming despair. Scientists believe these negative experiences may be linked to the brain's fight-or-flight response. As the body senses its imminent demise, the amygdala, the part of the brain responsible for processing fear, goes into overdrive. This, combined with the chaotic firing of neurons, creates a perfect storm of terror. As researchers delve deeper into the mysteries of death, they face a host of ethical challenges. Capturing real-time data on the dying brain requires studying individuals who are at the end of their lives, often in hospice care or intensive care units. While these studies have the potential to revolutionize our understanding of consciousness, they also raise important questions about consent, dignity, and the limits of scientific inquiry. One recent experiment involved inducing near-death states in animals to study their brain activity. The results were groundbreaking but also sparked intense debate. Critics argue that such research risks crossing ethical boundaries, treating life and death as mere data points. For many people, the scientific explanations of near-death phenomena don't diminish their spiritual significance. In fact, some see these discoveries as evidence of a deeper interconnected reality that science is only beginning to understand. Michio Kaku himself has spoken about the possibility that science and spirituality may one day converge. While he approaches the subject from a scientific perspective, he acknowledges that the universe is full of mysteries that defy conventional explanation. Could it be that the brain's final moments are a glimpse into another dimension or a higher plane of existence? As technology continues to advance, our ability to study the brain in unprecedented detail will only improve. Emerging tools like brain-machine interfaces, quantum sensors, and advanced imaging techniques could provide new insights into what happens in the final moments of life. But with these advancements come new questions. If we could fully understand and even manipulate the process of dying, what would that mean for medicine, ethics, and society as a whole? Could we one day extend life indefinitely or even cheat death altogether? And if so, would we want to? The revelations about what happens in the brain before death are both fascinating and unsettling. They challenge our understanding of life, consciousness, and the nature of reality itself. They force us to confront our deepest fears and consider what it means to truly live. For Michio Kaku and other scientists, the goal is not to instill fear but to seek understanding. By exploring the mysteries of death, they hope to shed light on the profound questions that have captivated humanity for centuries. And while the answers may be uncomfortable, they also remind us of the incredible complexity and beauty of the human mind. In the end, perhaps the greatest mystery is not what happens when we die, but what we do with the time we have. One of the most intriguing aspects of this research is how it challenges our understanding of consciousness itself. For centuries, philosophers and scientists have debated the nature of the human mind. Is it simply a product of the brain's biological processes, or does it exist as something greater, something independent of the physical body? Michio Kaku has frequently spoken about the mind as a potential quantum phenomenon, one that transcends the conventional laws of biology. The idea that consciousness could persist beyond death, or even briefly exist in a detached state as the brain shuts down, is a notion that carries profound implications. Recent experiments have revealed that in the moments leading up to death, certain regions of the brain, particularly the prefrontal cortex and the parietal lobe, exhibit synchronized activity. These areas are responsible for processing identity, spatial awareness, and memory. This synchronization creates a feedback loop of awareness, allowing individuals to experience vivid and hyperreal sensations even as their physical body begins to fail. But what does this mean for consciousness? Some scientists speculate that this synchronization could serve as a bridge between the physical and quantum realms. If the brain acts as a receiver for consciousness rather than the origin of it, the implications are profound. Then this final surge of activity could represent the last interaction between the physical and the non-physical self. Time dilation in the final moment. One of the most startling findings in recent studies is the phenomenon of time dilation during near-death experiences. Many individuals who have returned from the brink of death report that time seemed to slow down or even stop entirely. Some describe reliving entire lifetimes in a matter of seconds, while others claim to have experienced events that felt like they lasted for hours or even days. This perception of time slowing down is not just anecdotal. Neurological studies have shown that the brain's temporal lobe, which is responsible for processing the passage of time, becomes hyperactive during moments of extreme stress or trauma. As the brain is flooded with neurotransmitters like norepinephrine and dopamine, its ability to process time is fundamentally altered. But there's an even more fascinating possibility, that time dilation is not merely a perceptual phenomenon but a quantum one. In quantum mechanics, the flow of time is not absolute. It can be warped and stretched depending on the observer's frame of reference. If the brain's final moments involve quantum processes, as Michio Kaku and others have suggested, then the subjective experience of time could become entirely untethered from the physical world. For the dying individual, this could mean that their final moments stretch into what feels like an eternity. Whether this eternity is filled with peace, terror, or something else entirely may depend on the individual's mental state and the cascade of neural and quantum processes unfolding in their brain. The role of quantum entanglement in consciousness. Another groundbreaking theory gaining traction among scientists is the idea that quantum entanglement may play a role in consciousness. Quantum entanglement occurs when two particles become so interconnected that the state of one instantly influences the state of the other, no matter how far apart they are. This phenomenon, which Einstein famously called spooky action at a distance, has been demonstrated in laboratory experiments but remains one of the most mysterious aspects of quantum physics. Some researchers believe that the neurons in our brain may exhibit a form of quantum entanglement, allowing information to be processed and shared at a speed and complexity far beyond what classical physics would allow. If true, this would mean that our thoughts, memories, and sense of self are not confined to the physical structures of the brain but are instead part of a vast, interconnected quantum network. In the moments before death, as the brain's biological functions begin to fail, this quantum network could become even more active. The loss of physical constraints might allow consciousness to expand outward, tapping into a universal field of information that some have likened to a cosmic internet. This idea has profound implications for how we understand life and death. It suggests that consciousness is not something that emerges from the brain but is instead something the brain tunes into, much like a radio receiver tunes into radio waves. If that's the case, then death may not be the end of consciousness at all, but a transition to a different state of being.